Before the B-4 engine roared to life, the world of rocketry stood at a crossroads. Humanity had reached a point where its ambitions stretched farther than its technology could reliably take it. Rockets were expensive, complex, and limited by engines born from the constraints of earlier generations. But the future demanded more power, more efficiency, more reliability. The dream of routine access to space had outgrown the tools built for the past. Into this landscape entered the BE-4, a powerful methane-fueled engine that represented a dramatic shift from the traditional blueprint of American rocketry. It was not simply a new engine, it was a new philosophy, designed from the ground up for reusability, scalability, and rapid production. The BE-4 carried with it the promise of transforming space travel from an extraordinary achievement into something steadily approaching normalcy. This engine, forged through years of trial, innovation, and technological reinvention, would come to define a new era. Its impact rippled across the aerospace industry, reshaping how rockets were designed, how missions were planned, and how humanity envisioned its future beyond Earth. The BE-4 began not as an experiment, but as a necessity. The aerospace world had grown comfortable with heritage engines, marvels of engineering in their own right, yet rooted in designs from decades past. Liquid hydrogen engines were efficient but costly and delicate. Kerosene engines were powerful but limited by soot, temperature, and performance ceilings that reuse only strained further. Methane offered something new, a fuel that burned clean, cooled efficiently, and allowed engines to be flown, recovered, refurbished, and flown again with minimal degradation. Designing the BE-4 meant embracing the future rather than replicating the past. Years of iterative development, fiery tests, and hard-earned breakthroughs slowly gave shape to an engine that could satisfy both commercial needs and national ambitions. The BE-4 was more than a technical achievement. It was a strategic pivot, a recognition that the next generation of rockets would not be defined by tradition, but by adaptability, speed, and reusability. In its chambers burned not just methane and oxygen, but the momentum of an entire industry seeking to evolve. When the BE-4 entered the stage, it signaled the arrival of a new chapter in propulsion technology. Methane engines had long been an engineer's dream, cleaner than kerosene, more manageable than hydrogen, and capable of powering rockets to orbit while surviving the rigors of return and reuse. But dreams require daring, and daring requires infrastructure, investment, and the willingness to break free from legacy systems. The BE-4 was the first American-built, large-scale methane engine to reach operational deployment. Its significance stretched beyond raw thrust. It represented a shift in the commercial launch market, a move toward engines that could be produced more rapidly and flown more frequently than anything before. It challenged competitors to rethink their own designs and accelerated a transition toward reusable launch architectures that were once considered experimental. With every test firing, every ignition, every measured burst of flame, the BE-4 carved a deeper place in the history of propulsion. It proved that methane engines were not theoretical stepping stones. They were the foundation of the next great wave of launch vehicles. A rocket engine is more than the sum of its parts. It is the heart that empowers a vehicle, dictating its capabilities, limitations, and the missions it can attempt. When the BE-4 became the propulsion core for next-generation rockets, it reshaped their identities. Rockets powered by BE-4s were no longer constrained by the fragile economics of expendable engines. They gained the flexibility to be recovered, rebuilt, and relaunched. turning each mission into a stepping stone rather than a climax. The engine's adoption marked the beginning of a new competitive age. Launch providers were no longer racing towards singular milestones. They were racing toward reliability, cadence, and cost reduction. As the BE-4 matured, it proved capable of supporting missions ranging from routine satellite deployments to high-stakes national security launches. Each successful flight helped redefine the baseline expectations for modern rockets. This was the quiet revolution, the kind that grows not from a single dramatic event, but from a steady accumulation of progress, flight after flight, ignition after ignition. The BE-4 became the backbone of rockets designed not just for today's missions, but for the demands of the decades ahead. The impact of the BE-4 extended far beyond the launch pad. Its emergence reshaped supply chains, manufacturing philosophies, and the strategic balance of the global launch market. In an industry historically shaped by government-led programs, the introduction of a high-performance commercial engine created a new center of gravity. Aerospace companies that once relied on government development cycles now had access to privately developed propulsion that could rival traditional engines. The ripple effects were profound. Launch competition intensified, costs shifted, new players emerged, empowered by the possibility of acquiring engines that would have been impossible to develop alone. The BE-4 contributed to a broader movement that blurred the boundaries between commercial and government spaceflight, creating a more dynamic and more unpredictable ecosystem. In this environment, the BE-4 became not just an engine, but a catalyst. Its success proved that private sector propulsion systems could reshape national strategies, accelerate innovation, and redefine the relationship between industry and exploration. Its influence reached beyond rockets and into the very structure of the space economy. Every engine leaves a legacy, but the BE-4's legacy is still unfolding. Its place in history will not be defined solely by its thrust or efficiency, but by the doors it opened. It marked a turning point in humanity's pursuit of accessible, repeatable spaceflight. It demonstrated that innovation could come not from repeating the past, but from reimagining the future. As new variants emerge, as rockets evolve, and as human ambitions expand beyond Earth, the BE-4 stands as a reminder of the moment when the industry truly embraced reusability as the norm rather than the exception. Its influence stretches into the designs of future engines, future vehicles, and future missions that will push beyond Earth orbit into cislunar space and eventually toward other worlds. One day, when rockets carrying settlers, explorers, and dreamers lift off toward destinations yet unimagined, the lineage of those engines, the design philosophies, the fuels, the architectures, will trace back to the moment methane engines proved their worth. The BE-4 is not the final chapter of propulsion. It is one of the opening chapters of a much greater story. In the end, the BE-4's impact is captured not in numbers, but in moments. The blinding flash of ignition, the tremble of the ground as flame meets steel, and the rising arc of a rocket carving its path through the sky. Each launch marks a continuation of the legacy that began when humans dared to rethink the way they reached the stars. The world of spaceflight will never be the same. Engines will grow more advanced, rockets more capable, missions more ambitious. But the BE-4 stands as a symbol of the era when the industry pivoted from cautious steps to confident strides, from occasional triumphs to routine access, from aspiration to capability. It is a testament to innovation, persistence, and the relentless pursuit of improving the engines that carry humanity beyond Earth. The BE-4 did not simply power rockets. It powered a transition, a transformation, a reimagining of what is possible.